Hello and welcome to this second film in the Reactions and Equations series. This one, well, now that we've looked at the different kinds of reactions you're going to see in semester 1 and 2, in semester 1, this one deals with how you're going to write equations for those reactions. Okay, so hopefully by the end of this film you'll know what should and shouldn't appear in those equations, and you'll have had some practice looking at those main reaction types, and you start to remember them hopefully a bit better if you don't remember them that well already. Okay, so this is a very similar sequence of slides to the last film, so I'm just going to rush through the first few slides because we've seen them before. They're the main reaction types, they're the negative ions that we see in acids, and this is the first type of reaction, the acid-metal reaction. Right, so let's have a look at writing an equation for this, okay? Let's just write a symbol equation first, okay? We know that the formula of hydrochloric acid is HCl and the formula of magnesium is Mg. Okay, what are we going to form? Magnesium chloride and hydrogen. Okay, so MgCl2 and H2. Hydrogen is always H2. MgCl2 we have to figure out from the charges on the ions. Okay, so you must know your ion list. Okay, now what we can do is balance this equation. So balancing it is important. 2 H's, because we've got 2 over here, 2 Cl's now, and we had 2 over there, so that's balanced. Now let's break everything up that we can into ions. You don't need state symbols in these equations, but can help you decide what needs to be ions and what doesn't. Okay, solids will never be written as ions, only aqueous species, and gases will just appear as themselves. Okay, so here we are. Here are the ions: 2 H plus ions and 2 Cl minus ions. Okay, plus magnesium, which is a solid. We're going to make an Mg2 plus ion and 2 Cl minus ions. Okay, and hydrogen, which is a gas, so we just write its formula as it is. It's diatomic, always H2, never just H. Okay, now remember what we can do is cancel out any ions that haven't reacted, or spectator ions. So the Cl minuses are unchanged, and there is our ionic equation left in red. Okay, if you want, you can rewrite this, but there's no need. Let's move on to the next one. Nitric acid and calcium. So symbol equation first again. Bear in mind, if you can't write the ionic equation, but you can write the symbol equation, that is going to be worth some marks. It's just not going to be worth as many as writing an ionic one. What are we going to make? We're going to make calcium nitrate. Calcium is a 2 plus ion, so it's going to have 2 nitrate ions with it because there's 1 minus. Okay, plus hydrogen, because it's always acid plus metal makes salt and hydrogen. Okay, to balance it, we need 2 H's. That's going to give us 2 nitrates as well, and 2 nitrates over here. So we're balanced. Now let's just split up into ions anything that is AQ. Acids are always AQ. You can check whether this is AQ by checking whether it's soluble or not. If it's soluble, it will remain in solution. Okay, there's a gas. So 2H plus 2NO3 minus plus Ca makes Ca2 plus AQ. Sorry, I'm not including the state symbols here. Plus 2NO3 minus plus H2. Okay, so what hasn't changed? Well, the nitrate ions are unchanged. Okay, calcium has, because it's now got a charge where it didn't before. Okay, so once again, a balanced ionic equation. We've got rid of the spectator ions. Okay, there's a few more examples to go, so I'm just a bit mindful of the fact that this is going to be quite a long film unless I go quite quickly. So I'm going to try and speed up a little bit. Remember, you can pause anytime you like. Okay, here's the next kind of reaction, the acids and bases. All right, and here are 2 examples. Sulfuric acid, H2SO4. That's a strong acid, so we're going to split it up into ions, okay? And copper 2 oxide. Copper 2 oxide is actually insoluble, so this is going to be a solid. Okay, so copper 2 oxide is a solid. That means we're not going to split it into ions in the ionic equation. What are we going to make? A salt and water. Copper sulfate is our salt, and water, which is always a liquid and never gets split into ions in the equation. Okay, AQ, because it does dissolve, you can check its solubility on the datasheet. Let's write out all the ions now. Let's just check that it's balanced. It is balanced. Okay, so 2H plus SO4 plus. This is a solid, so we don't split it up into ions. Plus CuO makes Cu2 plus SO4 2 minus plus H2O. What's changed and what hasn't? Well, we're going to cross out the things that haven't. Sorry, I need a 2 minus charge there. So we're going to cross out the sulfate ions. Okay, so we see that the acid is reacting with the base to make the salt and water, but the sulfate ions didn't react. Here we go again. Here's a different kind of acid. Got to watch out here. Here's another thing to look out for. I'm not writing these things down as things to remember, but you should make a note of this. This is a weak acid. It's not going to split very much into ions, so we're not going to write it as ions in our equation. Sodium hydroxide, that's usually a solution, but they'll specify if they want you to get the state right. Let's just assume it's a solution here. What are we going to make? We're going to make sodium ethanoate, NaCH3COO. In case you're wondering how on earth is he getting these formulas, if you don't know that, then you've probably forgotten your ion list. And water, which is a liquid. Okay? Okay, so check if it's balanced. Everything's balanced there, so now we can write the ions. Remember, weak acid. Weak acid, so we're not going to write it as ions. Okay, so here we go again. So we're going to write that as CH3COOH plus Na plus OH minus. Here's an Na plus ion again, because this thing is soluble. You can check if it's soluble on our data sheet. Stop this film, slow down and look at your data sheet if you're not sure what I mean. Okay, so that you're sure of what I'm talking about here. Remember, you can go as slow as you want. Okay, and then water, a product. Okay, has anything not changed? Well, yes, the sodium ions haven't changed. Okay, so we cross them out because they're spectator ions. Moving swiftly on to the acids and carbonates. Remember, they're the general rules, and here are our examples. Hydrochloric acid, remember, is strong. We're going to show that as ions in our equation because it splits up. It's a strong acid. Copper carbonate. Copper carbonate is insoluble. You can check that on your data sheet. So this is going to be a solid. What's it going to make? Well, it's going to make copper chloride. Copper is a 2 plus ion, so it's going to be CuCl2 and water and carbon dioxide. Carbon dioxide is a gas. Water is a liquid. We don't write them as ions. This is aqueous. It's soluble, so it's going to break up into ions. Here are, just double check that it's balanced. It's not, so I put a 2 in there. Just slow down and check that if you want. Okay, 2H plus 2Cl minus plus. I'm not going to break this into ions because it's a solid. I am going to break this one into ions because it's dissolved. And things that are liquids and gases I always leave as their formulas. Okay, can I cross anything out here? Well, yes, because the chloride ions haven't changed. So I'm going to cross them out. If I want, I'd rewrite that whole equation without those spectator ions. Remember, you will get marks for this, but you'll get twice as many for a correct balanced equation. Okay? And finally, for carbonates, right here again is a weak acid. Remember, weak acids don't really ionize. They're weak electrolytes. They don't split up into ions much. They dissolve well, but they don't split into ions much. So we're going to write that as its formula in the equation. Sodium hydrogen carbonate. Okay, again, this is an ion that a lot of people will forget. HCO3 minus. So 1 plus, 1 minus, there's the formula of it. What are we going to make? Well, still a salt and water and carbon dioxide. This time it's going to be sodium ethanoate. Oops, get rid of that minus charge. And water and carbon dioxide. Let's check on our data sheet if these things dissolve. That does. It's aqueous. Okay, and this will be a solution usually, but it could be a solid, but they'll tell you. Okay, so now let's write out anything that's ions. I'm not going to change that because it's a weak acid. Same thing with weak base and any weak electrolyte. This is ionic, so it's Na plus and HCO3 minus. And what have we got here? We've still got a sodium ion, we've got an ethanoate ion, and we've got H2O and CO2. What's changed? Well, everything apart from the sodium. So we can cross out the sodiums because they're a spectator ion. Okay, that's 3/4 of the reaction types done. Remember, you need to go back and check it. If you want to ask any questions, do that. Okay, these are really important things to be able to do. Final kind of reaction is the precipitation, remember? Okay, here are our two examples. Remember, we're just going to swap ions around, but anyway, let's just write down symbols first, because we can do this and we'll get half the marks. Okay, so lead nitrate, Pb2 plus and NO3 minus, sodium carbonate, Na2, CO3. What are they going to make? Well, we swap the ions around. We're going to make sodium nitrate and lead carbonate. Okay, to balance it, I need 2 of those. I can look on my data sheet and see which of these are soluble. The ones that are soluble will be in solution, so they're AQ. The ones that are insoluble, they can't stay in solution. They're going to have to form solids. Why is that important? Because you're not going to write them as ions in your equation. Right, here we go. Here's all the ions. Pb2 plus 2 NO3 minus plus 2 Na plus a carbonate ion, making 2 Na plus 2 NO3 minus plus, and I've got to leave that as a solid. Now look, if you remember from your precipitation reactions film, this is the only thing that has changed. So we're going to cross out all the spectators and we're left with just the precipitate and the ions that it was made out of. Okay, if you can do that in your head, then you don't even need to write all this stuff out. Remember, you'll get half a mark for doing it like that. Sorry, half the marks. You'll get all the marks for getting the balanced ionic equation. You don't have to write both, just the balanced ionic one. Finally, hydrochloric acid, HCl plus AgNO3 for silver nitrate. What's that going to make? Swap the positives and negatives around and we make HNO3, which is nitric acid, and AgCl. We can look up now on our data sheet what's soluble and what's not. All nitrates are, okay? And all acids are as well. Okay, but AgCl is a chloride that isn't soluble, so it's going to form a solid or a precipitate. What are all the ions here? H plus Cl minus, Ag plus NO3 minus makes H plus NO3 minus plus, and I can't write a solid as ions, I've got to write it as its entire formula. Cross out what hasn't changed, and that's the H plus ions and the nitrate ions. And again, we've got the formula of the precipitate coming from the ions that it's made up from. Okay, there we go. That's all the different kinds of reactions we've practiced an equation for. Some really important points in there. There are no shortcuts to this. Lots of things to remember, and it's really important that you practice it. There's no point practicing it if you can't remember the formulas of ions and molecules, because you'll just not know what to put in the equations. So if you still don't know your ions list, please go and learn it now. Okay? Anyway, the next film that you're going to see is about predicting the observations that you'll see in reactions. So a little bit simpler than this, I suppose, but then again, if you can't do this, you'll struggle with the next bit. All right, so make sure this makes sense. If you need a bit of help, then ask.